Welcome to ControlCore Tech. Every day, we use incredible technologies without thinking about how they work. On this channel, we explore the engineering behind the modern world with clear explanations and engaging animations. Imagine flipping a light switch. The light turns on instantly. But have you ever wondered where that electricity came from? Before it reached your home, electricity began its journey at a power plant, where it was generated. From there, it passed through a step-up transformer to increase its voltage, traveled hundreds of kilometers along high-voltage transmission lines, reached substations where the voltage was reduced, continued through local distribution lines, and finally arrived safely at your home, ready to power your everyday life. Today, we'll follow electricity on its incredible journey from generation to your home. Generating electricity, every journey begins at a power plant. Electricity can be generated from different energy sources, but they all have the same goal: producing electrical energy. Moving water spins a turbine, which drives a generator to produce electricity. Wind power uses the energy of moving air. As the wind turns the turbine blades, the generator converts that mechanical motion into electrical energy. Solar power works differently. Solar panels capture sunlight and convert light energy directly into electrical energy without using a turbine. Natural gas contains chemical energy. When it is burned, it produces heat that creates steam. The steam spins a turbine connected to a generator, producing electricity. Nuclear power uses uranium fuel. Nuclear reactions release heat, producing steam that spins a turbine and generator to generate electricity. Although these energy sources are different, most power plants produce electricity by spinning a generator. Inside the generator, rotating magnets create a changing magnetic field that produces electricity in copper coils through electromagnetic induction. However, the electricity leaving the generator has a relatively low voltage. If we tried to send it across the country like this, much of the energy would be lost as heat. So engineers found a smarter solution. The step-up transformer right outside the power plant sits one of the most important machines in the electrical grid, the step-up transformer. Its job is simple but powerful. It increases the voltage from around 11,000 volts to hundreds of thousands of volts. Why increase the voltage? Because higher voltage means lower current. Lower current reduces energy losses, allowing electricity to travel long distances efficiently. Transmission lines. Now electricity begins its long journey. It travels through high-voltage transmission lines supported by enormous steel towers. These lines connect power plants with cities, towns, factories, and industries. The towers keep the cables safely above the ground while carrying huge amounts of electrical power across hundreds of kilometers. The substation. When electricity reaches a city, it enters a substation. Here, powerful transformers reduce the voltage to a safer level for local distribution. The substation also contains protective equipment that detects faults and prevents damage to the electrical grid. Without substations, delivering electricity safely would be impossible. Distribution network. Electricity now travels through smaller distribution lines. These lines run along roads and neighborhoods. Near your home, a distribution transformer mounted on a utility pole or inside a green cabinet reduces the voltage once again. Now the electricity is finally safe for homes and businesses. Inside your home, electricity enters your home through the service cable. First, it passes through the electricity meter, which measures your energy usage. Next, it enters the breaker panel. Circuit breakers protect your home from overloads and short circuits. Finally, electricity flows through the wiring inside your walls to power your lights, television, refrigerator, computer, charger, and every other appliance. The moment you flip a switch, the circuit closes and electricity begins to flow. From a spinning turbine inside a power plant to the light in your room, electricity travels an incredible journey in less than a second. Thousands of engineers, transformers, substations, and power lines work together every day to make this possible. The next time you turn on a light, remember the amazing engineering behind that simple action. If you found this video helpful, don't forget to like, subscribe, and turn on the notification bell so you never miss our future videos. If you have any questions or suggestions, leave them in the comments below. We'd love to hear from you. Thanks for watching ControlCore Tech. See you in the next video.